All right. Well, we're ready to go. So next we're going to hear from Brad Midgley. He's actually local. I could throw rocks at his house almost from mine. Um, and yeah, looking forward to some robots and JavaScript. So take it away, Brad.
Thank you. I've been wondering who was throwing rocks at my house. So thanks for straightening that out.
Shh, nobody tell.
Okay. All right, so before we start, I want to see the chat window hum. So can everyone say hello and what city you're in? Say hello in your native language. All right. Okay, just a couple from, all right, Cyrillic. Yep. Okay, while that's coming through, I am going to talk about JavaScript. And this is going to feel like looking through a microscope after hearing Jessica, because this is just one tiny little focus problem, and it's a fun thing. So I came into this because basically seeing when my daughter was doing Lego League and seeing the tools that she was using for this. Now, you've seen this before where you have a flow chart that you drag and drop, and it's an interesting way to help kids learn how programming works. But I think there's a big opportunity there to see more, and so I want to talk about some ideas that I had in making some more things work. So whenever you're writing software, you have a certain surface area, and this is the interaction that your software has with the world. So the picture over here is showing lots of different windows, and a typical program would only worry about one of those windows, and you only have a certain kind of user sometimes, a certain kind of expectation from them, and it's really a tight window and not a lot of latitude for what they can do with it. And sometimes you can get away with awful user experience because you force it on people, and it's just a consequence of using your system. So when you are dealing with the whole world, when you do things like robotics, you have to expand that surface area. And the idea that you have to accommodate more, it comes right to the front. So you're going to have to deal with the rest of the world, and you're going to have to be have to be the one who bends, so that you may crash and burn. My video. All right. So I love that we have just recently seen a landing on a comet, and I hope everyone here was using on bated breath, waiting for the results. And it turns out that when we landed, the European Space Agency, being we, I mean humanity, when we landed Philae on the comet, it sadly bounced a few times before it came to rest. But everyone in the world, I think, should have been watching this. And it was exciting stuff and just really satisfying to see that we were able to get so close to the actual desired result. And the landers as well. We've had lots of success and failures. And one of the things that I love about this is we have these huge delays when you're talking to these remote objects that we've built. You've got almost a 1 hour delay talking to Rosetta. And this leads to a lot of design decisions. You've got to mostly be autonomous. You can't be headed toward a cliff and wait for the next command before you do something about it. And so one of the really important design issues around robotics is that you make a state machine to drive your robot, to drive your behavior. But it's best done if it's a hierarchy. And this comes almost directly from how we think about the world. Like, we have the hierarchy of needs, and you've heard of that before. So things like being able to breathe, it becomes very important to you if you can't do it. It's going to be more important than eating. It's going to be more important than making money today. And you have the same kind of thing when you build a robot that's effective. It needs to be able to do things, important things need to take precedence. And it can't be easy to accidentally lose some important behavior. That's another thing. Now, before I go any further, I'm going to tell you that I have written all of my sample code in CoffeeScript. So I'd like everyone in the chat window to just give me a hooray or a boo right now and just get that out of your system. Now, I'm not in love with CoffeeScript. In fact, sometimes I don't like, it has some masking, scoping behavior that I don't like. But to a large degree, it gives me a great signal to noise ratio. Thanks, everyone. I don't know why the chat window just took over the screen. So this is what it looks like when you put all the behaviors in a hierarchy and put all the pieces around it so that you can drive it. On the left, you have announcers, and they're going to generate all the events for your system. Things like you're moving, you're turning directions, you've reached a goal in proximity, all kinds of events are coming through, and they're coming through constantly, hundreds of messages. And then what I've done is I've put one single object in charge of bringing all those together and then managing the state in your behaviors. So each time an event comes through, the bot delivers it to the hierarchy, and then the hierarchy, one of the nodes in the hierarchy might return a new state. And if you do get a new state, you record that, and then you alert the new state that it's been entered. And then back here at the back end, you've got to do something with the state, and this is where you drive or you do or you move something, and that goes out to the drivers. Now, the hierarchy part falls in when you deliver events. So I'm showing events going 1, 2, 3. This is the same event. So let's say that this state up here with the X is something like discover sunken treasure. And you've got a state here that says if your battery is low, you need to surface. So if you have a battery event that says my battery is fine, it's going to be delivered to the lowest state. It's not going to ask for a change of state. It's going to be delivered to the medium one, and there's going to be no change, and it's going to be delivered to the top one. And everyone ignores that message. That's just all fine. But if you get a battery message that we're almost depleted, when it reaches this middle state that cares about the battery, it's going to return a new state that says, bail what you're doing now. And typically, it will push to the parent state. That's almost always what you do when there's a failure. And so this middle state would return a new state. It would be this one, and then you'd take some action. You'd head to the surface. You'd save your submarine. Okay, so I have lots of different kinds of classes and objects, and we're meeting the cast now. So first, what do the announcers look like? I've already prepared you for the CoffeeScript, so here it is. This is just very basic stuff. It's JavaScript. I want to hear every 1,000 milliseconds. I want a message to be pushed into the event machine, and it's got to be. I just used anonymous messages. That's what this timer :1 is, and just kind of vanilla messages. And that's what this compass adjusted is. So every time an event comes through that's a device orientation event, this listener takes that thing and adjusts it according to some kind of calibration, and then pushes that announcement into the system. So those are announcers. So behaviors are what you build the hierarchy from. One of the behaviors is robotiming. So this is an important one for capturing things like you've got a limited time to do something, or you want to give up on something after a little while, or you really just need to time box something. You expect it to always run the clock out. But this is a really useful behavior. And a few times it saved me from having to chase the car as it went out of control. So there's a battery monitoring behavior, and I talked about this one as well just earlier. You want to know when your battery's going low, you need to stop what you're doing and head back to base. There's a finding behavior, so you can attach a GPS location to one of these states, and then what it'll do is every time there's an event that's a location event, it'll calculate where you are in relation to that thing. And it'll be able to do things like pop you out of this behavior if it decides you're within the radius of that object. And there's a sequencing behavior. So if you just want a bunch of things to run in sequence, you stack them on top of a sequencing behavior. And there's a flagging behavior, which sounds like it's something that moderators do. It's a behavior that flags. So when you enter this state, what it does is it waits for the next location event. And when it sees that, it'll execute the closure that you've passed it. And usually what you do with that closure is you insert a finding event somewhere else in the state machine. So we love that it's self-modifying, right? This is one of the things that makes it exciting. And there's a steering behavior, so it's not enough to have a finding behavior. That one, it just gives you an idea of where to go, and then you compose on top of that a strategy for getting somewhere. So you could switch out the strategy, like you could decide that my strategy is going to be to average out compass readings before I take action, or it's just going to be, I'm just going to always follow what it says I should do. Or maybe you have a flying device and you're going to need to know how to deal with altitude. You know, that could all be part of a specialized steering behavior. And then you need a way to drive your stuff. So this is the first car that I came up with, and you can see this little double pilot harness up here is where I put my cell phone. And yes, this is a GoPro. I think it might look weird to everyone to have two cameras on the car, but it actually turns out to be a lot of fun to watch what the phone is doing as it's flying around. And it actually is not a great placement for the phone because when you hit things like a curb, it tends to throw the phone right in front of the car. So it's a little precarious. So I'm not going to dig too deeply here, but I just wanted to show you that all of the logic for dealing with this car can be contained on one page of code. And what it does is it uses the JavaScript APIs for connecting to a TCP socket. The way it works is when you turn on this car, it's called the Wi-Fi racer. When you turn it on, it appears to be an access point. And you connect your device to the access point, it gets an address, and then there's a certain address on this network that you can send commands to. And I had to find all this out by sniffing the connection. They give you an app that you can install, and I installed it on my Android device, and then I sniffed the connection to see what it was sending. It turned out it was sending UDP commands, which there is no JavaScript API for UDP. So, but fortunately, I found that it also worked on TCP on the same port number. So I was super excited to get that. One very sad thing about this car, and it would have been so easy to fix, is when it gives you an address, it says, oh, and by the way, I am the default route to the internet. At which point the phone turns off its cell radio basically and doesn't use the cell radio anymore. And it's so sad that the car is not really a default route to the internet, because then you can't use the phone's built-in cell radio to do any interesting communications. Okay, and this is the little car, what I call the little car. This was sold by SparkFun for a little while. It's called the iRacer, and it's a tiny Arduino on a board that has a Bluetooth controller. And again, you might see a pattern here. I didn't have to do any soldering. The only thing I did was cut a hole so that I could put my phone in it and not have to tape it down. So these things, what I do with these is I just have to turn on the car and then go into the phone's regular control panel and pair with the car over Bluetooth. But there's a dirty little secret. Because I'm using Firefox OS for everything, and that's because we love JavaScript and doing everything in JavaScript, there's not yet a Firefox API for talking to a Bluetooth socket, a bare socket, an RF socket. So what I had to do, and you'll love this, I just used, it's like a total MacGyver move. I used Netcat combined with a little shell script to build a tiny web server that I shell into the machine, and I run this tiny web server, and it listens for web commands and translates those into commands that it pipes out over the RF comm. So we kind of had a problem here, and I was able to get around it. One of the reasons I like this little car is because you don't lose your default route. You can still communicate with the world, and that's important for later on. Okay, so I built a sample app out of all this. Yeah, that's exactly where the questions are headed. So what I did is I took the framework is one component, and then I built an app around the framework. And so these are the two main JavaScript files that are on my phone. So I built this app. I use jQuery Mobile. I think it's not actually the preferred way to do stuff in Firefox OS, but it's what I was familiar with. And I just tacked a bunch of buttons into a user interface, and each one of these buttons just creates an event and injects the event into the state machine. They're not special. They just happen to say what their button name is when they send that event through. And then this black thing is the accordion widget, and I'm thwarting the accordion widget so that you can see what the current state of the machine is. So for example, right here, I've punched the drive button. So a drive event went into the state machine, and this updated to show me that this is the current state. It puts a little asterisk by it, and it expands the accordion so you can easily see what's happening. So let's go. Let's have a quick, well, before we do the YouTube time, let's look at my desktop. And I've got here the Firefox Web IDE. So has anyone worked with this? Pipe up in the chat if you've done anything with Web IDE. Not a lot. Okay. It's a new thing, but it is pretty amazing. And it's fun. I've done mobile development on other devices, and you can get the job done. I think it's a little more fun in this platform. So here's my app. This thing constructs my like 10 states, and it also wires up the accordion down here. This is wiring up the accordion widget, and then this is instantiating all my announcers. So let's try running it. I'm sure a live demo will work. This is the Firefox OS 2.0 simulator. So you can see my accordion. This looks great in Retina, by the way. My accordion widget is here, and I can drill in and see what my state machine looks like. So I have a ready state, and under that I have a limiting state, and then one here that says require calibrated. As I drill in, you'll see here's an empty one. And this one is meant to be the place where you put GPS locations. And then there's also another state over here, which is for calibrating your compass. So what happens is, let's see if it will work. What I can do is tell it, I want to store the current GPS location in the stack. Okay, it came through really fast, and what that means is, I think that means it worked. I haven't used the simulator as much. Okay, so we have one point. This just got created in our hierarchy. And it's composed with one of the steering strategies, the basic steering strategy. Right now there's only one. So if I tell it I want to go, if I hit the go, it'll jump to that state that is the runs through all the GPS flags. So let's just try that out. Okay, so the first thing it does is actually, it says, oh, I've got to require that you calibrate your compass before we can follow this GPS course. So it's going through the compass calibrator action. And as soon as it finishes calibrating the compass, then it jumps here. It's jumped to trying to follow the GPS course. And it actually decided, oh, I'm already there, because the GPS always returns the same location. And let's watch it in real life. That's more interesting than this. Okay. So here's me putting down a flag over this string
I'll put
cover.
0.2 right here. Stored it, and just make sure it's there. Points 1 and 2.
Thanks, Chuck. Okay, after doing that, then I carefully take my precious, precious phone and put it and jam it in front of the car and tell it to go full speed. I turned down the sound a bit. Now, one thing that you'll notice is you'll have to look away if you get motion sickness, because I'm not doing any kind of cleanup of the compass signal or the GPS signal. I'm not trying to average anything. I'm just saying, if you read the compass, you read the GPS, turn if you're off course, go straight if you're on course. That's why it kind of fishtails. Okay, so it sounds like the audio from the YouTube was still making it to you guys. Is that true? Okay. I turned it down on my side. That just means I couldn't hear it, but I guess everybody else could hear it. So let me tell you what is happening in this crazy video. So it's going like this because it's reading raw compass and GPS events, and it's not trying to correct or eliminate noise or average the signal or anything like that. And you can see me in, and that's exactly why it was turning, because it kept thinking it was off course. You know, it would turn off to the left a little while, and then after a while it would think, oh, I'm way to the left, and then it would turn to the right, overcorrect, and so it was just kind of all over the place. I could probably tighten this up by cleaning up my input signals, by averaging those, and also I might be able to clean it up with my, my driver algorithm. This car is really interesting the way you drive it. You have to give it a command, and then it follows that command for about half a second. So what you, and if you tell it to turn, if that's what you tell it to do, it goes forward for just a part of a second, it turns for just part of a second, and then it goes straight again. So you have to like start to turn before you move it and keep it turned until after you stop. And yeah, so there's a lot going on there. I won't play it again, but it makes it to the grill, and then it turns and goes off to the next goal. And I'm not quite brave enough to put this on anything that flies, because I'm pretty sure I will lose that as soon as it takes off. In fact, I drew a slide for that. So yes, I have a huge dent in my fancy phone from the time that I forgot I had a test. I had a test location that was up in the hills, and it decided to try to go up in the hills. All right, great. So we already showed this. I managed to get the screen working. I'm going to just reiterate what I'm doing in the calibration. So I've got this interrupting state that is overriding everything. And then when you jump into the GPS course. This interrupting state, it evaluates a closure to determine if it is going to allow that to happen or if it's going to jump in. And the evaluation it makes is do I have a calibrated compass announcer? So it just looks at it actually queries the bot, do I have a calibrated announcer? If I don't, then I interrupt everything, I save what that state was, because it could be anywhere in here. You could be at a child state. You want to save that. And then it jumps to calibrating. Calibrating is the sequencing state. It's a subclass of sequencing. And so what it's going to do is just execute each of these in turn. So as it's driving forward for 2 seconds, it's collecting GPS data. As it's turning, it collects data. And then as soon as it's done with that, then it comes to registering. And what I found was a couple of different phones, even both running Firefox OS, had different ideas about how a compass works. So this flame phone, which is the one that I was so sad I put a dent in. This one, for some reason, it basically gives you a compass that's backwards. So when you're pointed west, I think it gives you a 90-degree heading. I think it's backwards, whatever that is. So what I did then is I have it, sometimes you'll see an app that says you need to turn your phone around so we can get an idea of what your compass is doing. We can't really do that, but what we can do is we can drive in circles. So after we've driven in circles, then we look at the signal from the compass. And you can tell if it slowly falls and then spikes, you're turning one direction and you've got a compass that's oriented one way. But if it spikes and then slowly falls, then you've got the other kind. So that's how we figure it out. Chuck is mocking. My car is really fast, you guys. It can get away from me. I'm going to skip this slide. This is basically what I just said. Oh, and I think actually when I asked in the forums among the Firefox guys, I think they were saying that the old OS had it backwards and the new OS has it right. So maybe we're all right. So all the apps in the store though must be coding it for backwards, because if you want to use an app in the Firefox store with this that does a compass, you need to hold it above your head to have it actually giving you the right heading. Okay, so what else can we do? So the other thing we can do is have a bot that drives all the others in a game. So we need communication between the devices. And I played around with things like WebRTC and realized I absolutely have to have a server. Even if you use WebRTC successfully, you still have to have a server to exchange the secrets. So what I did is I got the Beaglebone Black, and I got it for something totally unrelated, and I realized it would be great for this. So I put a message queue on Beaglebone Black. I wrote a message queue and put it on there. When you want to play, you punch a button that puts the car in I'm ready to play the game mode. And then on the game controller, which is running the same software, right? You're not running a different app on each phone. You're just putting it in a different state. On that app, you punch a button that says start the game. But what it does is it goes to that same spot in the state machine where I collect GPS flags. And it just says, oh, this is the contest. It sends all those flags out in the request in the game message. And the rule is that a car needs to hit every location, and then the car that hits the last location wins. Don't laugh at my rules. So here's the Beaglebone. So I really like this thing. The hardest thing about this was telling it to be an access point, which wasn't awful. And then the the really slick thing about Beaglebone is JavaScript is the preferred language. You know, if you've worked with Raspberry Pi, by the way, the Raspberry Pi 2 will blow this thing out of the water, I'm sure, but it's still not going to have this feature that I love, which is that JavaScript is the language that is preferred for doing it. And it has a module that you can require in JavaScript that gives you GPIO control to all these things. And there's a Cloud9 IDE that you get out of the box. And the really cool thing for me was there's a startup folder. If you put a Node.js program in the startup folder, it will run it on boot. And you don't easily get that on the Raspberry Pi. In fact, we kind of lost this when you went from Arduino to Raspberry Pi. If you've ever written code for Arduino, you write one program, you turn the thing on, and it runs that one program. And we kind of lost that in going to the Pi, and I really hope they get inspired by the software that the Beaglebone guys did. So I wrote a message queue in one page of, sorry, again, CoffeeScript. And what I do in this thing is I just have a get and a post. And when you get something, we look up your session and we deliver the message, the next message for you. And then when you post, we look up your session. We might actually not find you. You might be a brand new session, in which case, you know, you're sending an anonymous object of any size, by the way. And we stamp your sender ID here, and then we also stamp a serial number on it. And then we put it in the message queue. The message queue grows unbounded in memory so that anyone can join at any time and they'll hear everything that went on before they joined. But that's okay, because if you need to reset your message queue, you just pull the power. Oh, and also, I noticed that Sting knows how important it is that messages and bots get along together. So here's my game. So here's what the messages look like. So when I want to start a game, by the way, when you send a message to the queue, you just send this part, and then the message queue stamps it like the sender. So when you want to play, you send a game message that says it's running now, and you give the flags in an array. And when you want to say the game is over, you say how much time elapsed, and oh, by the way, no one won. Or during the game, you can send a message that says car number 2 claims to have hit, you know, pylon number 0, and the next one is 1. During the game, you are supposed to announce your location so that the game controller can respond. Okay, so there are lots of attack vectors, and I want to enumerate them. And please tell me if you think of another one. So I've told everyone in the world the queue's secret. I'll start with the harder ones. So you could fabricate a session key in theory. The next one is the queue is using HTTP, so it might be you can intercept traffic that way. The other thing is you can reset the queue. If you jangle the power, all the messages disappear. The sample code that I run doesn't check to see who's trying to run the game, so you can't have 2 games running at the same time because they'll get confused. Really, this is for the reader to fix, right? It's an exercise for the reader. Another fun one is if you can talk the phone into opening a web page that has an image reference like this, the car will start driving. That's a fun one. And what does this image look like? It's the car driving off the desk. You could also try to DOS the queue. You could fiddle with the Beaglebone script. There is no authentication when you connect to the Cloud9 IDE. Anyone can do anything they want. You can also announce that you're at the last. You can just zoom to the last location in the maze, in the compass course, and you win. Or you can just claim to be there and you win. I see some good ideas coming up in the chat. So I want my kids to work on this. So hopefully they'll listen to the talk and see all the attack vectors here. And because like every other parent, my greatest fear is what will my kids do with a 0-day exploit and how will I deal with that? But I think my kids aren't going to do that unless I raise the stakes a bit. So I told them I would buy them a car if they can beat me at this game. It just won't be something they can take to senior prom. Okay, so I've kind of set the base camp here. And now I want to take a side trip and run at the peak. So we're working in a language in which you can ask all these questions, and the answer, of course, is yes for all those things. We're in using a very dynamic system, and it's one in which we can create object factories. We don't just have to create objects, we can create objects that create objects. And they're usually called classes. And another thing that we can do is we can have new ways to manipulate objects, and we don't have to use eval. And we can, what I really want to prove here is that we can interact with people and be able to build up new behavior. I think that if we can get that, if I can get that solved, then it'll open the door for things like genetic programming. So genetic programming is an old idea where you take two pieces of code that presumably both work and you jam them together and you test it and see if it works. And how you jam them together is really the $20,000 question, because jamming code together doesn't work. But if you're using a hierarchy of state machines, you can slice things together and splice them, and you can have things that is a composition of behaviors. And it might actually do something that you want. So I think it opens up some really cool possibilities for genetic programming. And self-describing, so systems that we know of that are kind of self-describing in that you can use the system to build behavior in. So small talk, Lisp, for. And what I would like to do next is make it so that we can build an application that is self-modifying through the user interface. So I want to receive events from the UI and have the side effects, instead of just sometimes building an object or manipulating the existing state machine. I want to build a class when that happens, or modify a class. And I'm starting to brainstorm on this, and I'd love everyone's input on it. So I think the way to start this out is to let the user choose a class from the namespace. So all the behaviors are going to have to be in one namespace. And when they choose one of those, it's going to subclass it. And then they can say, well, it's going to have these child states. And then we could record those in a class variable. That would allow us to make that stick. And then the user would give this new thing a name and put it back in the namespace. And that all sounds great, but there's a piece, the hardest part is the event handlers. Like if you're going to get events or if you're going to get entry, this is really the connective tissue of a state machine. It's what makes things work. It's what makes states different from each other. And so this is really one of the hardest things. And this is where I will kind of do a U-turn, because at the beginning of this talk, or in my proposal, I said we needed to stop using flowcharts to write programs for doing robotics. But I think as I look at this, that events and entry handlers might be a good fit for a flowchart. So I hate to admit it, but we might actually arrive right back there. And I'll write up, and here's some code to show what this might look like. So the base class would be modified so that it looked inside of a class variable at construction time and instantiated objects from that variable using the list of a list of things to construct the thing with. And then what you would do is you would have some kind of parameterized builder of classes, and it would, this is putting it into the namespace, and this is finding the existing one that you want to specialize, and then you would just plop that into the behavior. That's actually, I think, the easy part. And so that is the end of the high excursion. It kind of makes me think of the Third Man on the Mountain movie. Do you remember that old Disney show? So some people have reached the peak. We know that they've done it, like with Smalltalk and some of the other systems. But I'm kind of scrambling around and not finding it where that secret passage is. So we need to make it. We need to find the way to make this, completely self-describing and be able to modify behavior. So, and this stuff should be exciting to everybody, I think. So we could make it a quicker reward to coding for a robot. And then one of the most important things is to get people to not think in this small surface area. Right? If you come into programming and your very first exposure is, I have to think of how it interacts with the entire world, then I think that's where you want to start. And if you need to, you narrow your scope down, but it should come that direction, not the other direction. And this is really, I love how this is all compatible with the Make movement. We have, I do stuff at our makerspace. I get together with them. In fact, I've given this talk about 4 times. Each time I give it, we make a list of things we need to add, and it's great. It's great fun. Okay, that's it for my slides. Let's go to question and answering.
Now I know nobody has questions about this. You can either type the questions in the chat and I'll read them, or you can raise your hand.
Okay, Cylon. I've looked at Cylon a little bit. I have all the stickers. I have Cylon stickers on all my things. I love that. So it looks like it's basically the driver layer. And you could correct me if I'm wrong, but I think it's the driver layer, which I've written just enough of the driver layer to get by to prove that things work. But I'd really like to do more. I'd like to do something with Lego Mindstorm. That's another Bluetooth device. Okay, type any other questions, any other thoughts?
I'm coming over to your house when this is over.
Yeah. Oh, and I never got a chance to show it off. It's right here. In fact, I almost knocked it off the table a minute ago. The big car. Yeah, like the message in a bot. That happened to come on the radio. I think
What is
I'm
keeping
mainly...
you from... Oh, go ahead.
Go ahead.
What's keeping you from going to bigger vehicles, or going bigger on the vehicles?
It was mainly trying to find something that didn't require any soldering. So I could definitely go with, I have another radio control car here that could do a lot better on the rough stuff, but I still have to wire things into the controller because it's the old-fashioned RF controller. But it's a good point.
EV wants you to do boats.
Oh yeah, that's a good idea. Boats would definitely be doable. You might have to worry a little bit about water. Oh, so Arcana, is that how we say that? So the problem with using the problem was using the big car. So I want to be able to use the big car and also talk to my message queue. These things seem to be incompatible because when you connect to the access point on the big car, it tells you it has a default route to the internet, so you can no longer use the cell phone's radio to get anywhere. And I've even thought, well, I could just put the message queue on that access point, but then no one else can reach it, unless I put multiple adapters on it, in which case it starts to get ridiculous. It's really sad because they could have flipped a switch in their firmware that said, I don't provide a route to the internet, and then it would have just worked.
Another question, have you done performance testing? How good is the performance?
I haven't really done performance testing. For a while, though, I had it rebuilding that accordion view every time an event came through, and the thing stopped. Because you're getting hundreds of events, and jQuery Mobile is doing some awful stuff in the DOM when you do that. And so it just got to the point where it would move, and then you could count to 10, and then it would move again, and it was funny. So I had to put that on a loop so that every second it would try to repaint, and it would kill all the previous repaint requests. And to answer Nate, I didn't do any programming on the vehicles, so I'm just using the means that they already gave me for pushing commands out there. Oh, and I didn't mention the big car. Whenever you send a message on that TCP socket, it replies with your battery level, which is really nice because that's one of the things that we want. And of course, the little cars, there's another problem, which is they're so small, it's harder to get them to register any useful change in GPS location. Oh, when I was, yeah, the sniffer, so Arcana again. So what I did is I had a jailbroken Android, and I ran Wireshark on the device. That's what I had to do to sniff the protocol. It wasn't enough to just have another device connected to the Wi-Fi. Couldn't sniff it that way.
We're going to go to in-person JavaScript conferences now and have cars all over the place.
Yeah, yeah, it's really fun stuff.
William asked, have you thought about sensors and building out environments?
Yeah, I've got a list of things that I want to do with sensors, like the camera. You definitely need to do more with the camera. I mean, you could do just like detect that you've reached a big white block on the wall or something. The other thing is speaker and microphone. You could have each car beeping and have the others listening for the beeps, for example. Echolocation. I mean, one of the things I like is you're taking a phone that has a ton of sensors on it, and you're not having to add anything. You just slam it into the car, and away it goes because it knows it has so many of those things going on.
So I skipped Nate's question. It was, is there any reason why you didn't build your own car?
Yeah, I wanted to have it be quick. I wanted to have it be something that other people could replicate. So that's why I chose such a popular phone like the Firefox phone, because everybody has that.
Yep. And then with regards to genetic programming, would prototypical OOP be better approach than inheritance? Because it seems like you're wanting to compose desirable behaviors.
That sounds like a question I need to think about. Maybe illustrate it for me. We could take this to the forum. Chuck set up a forum for us.
There's definitely a good topic right there for the forum. And then tying into your last point about learning, do you think learning programming for robots is helped by thinking in terms of events? I mean, is there an educational benefit to thinking this way?
think there is. I mean, I think that gives you kind of a more expanded view of the computing problem. And you can lock down on it and talk about, there are only certain things that can happen. But when you start, I like to start with the expanded view and think of events as anything that could happen. And crazy stuff happens, And I'm not a great artist. That's why I did such a terrible logo for my app, because I was expecting someone to say that's awful. I will give you an icon for your app. It didn't happen. Okay, so Bill has a link.
All right. Any other questions? I wish we could applaud in this thing, but yeah, that was a lot of fun. Thank you very much, Brad.
Yeah, thanks, Jim.
All right. Well, just to wrap up, I am going to do my best to get the videos into the forum tonight. I pretty much promised to have them first thing in the morning, so 10 a.m. ish Mountain Time, which is about noon Eastern. But I'm hoping to get them in tonight. So keep an eye out. You should get email notifications when stuff gets posted, and you can go change those settings in Discourse in the forum. So if you want emails, you want, just sign up for that. The URL for the forum is community.jsremoteconf.com. And the video, okay, so the recording gets the whole video, okay? So it will show the slides, the videos, everything that Brad showed. It will also show his picture. It'll show the attendee list and the chat as it went through. So I'm not sure how readable it'll be, but I'm going to post them in full resolution. So if that's what you're after, then it should be in there. Mark's asking for tomorrow's talk, same link. Yes, same link. If I emailed you because you didn't get the click webinar link and you used a token, it's the same token. All right, well, I just want to thank our presenters again, Jessica and Brad, and we'll go ahead and wrap this up. If you want to keep chatting, I'll leave this running until whenever, but I will stop the recording so that part of the chat won't be captured. And yeah, thanks again. Tomorrow night it's going to be Craig McKeechee talking about the anatomy of MV Star frameworks, and then we're going to have a Q&A by the Angular core team. So looking forward to that tomorrow.